So our next speaker is Josh. He works at Lyft, and we'll be talking about their switch to microservices. So here is Josh.
Shouldn't have been holding these mustaches. So, I don't know, let me get that going there. Oh, there we go. Great. So before I start, who wants a pink fluffy mustache? There we go. Over here, this light is blinding. I'm sorry if I'm not right in the center. Well, that's why I'm a developer advocate, not a quarterback. Sorry. All right. That's my one trick to keep you guys involved in the conversation. We might have more, so come see me afterwards. So yeah, as Greg mentioned, I'm here to talk a little bit about Lyft's switch to microservices and how that affected our API infrastructure. So if I really had my druthers, I would have preferred to call this talk "Amping Up APIs with Lyft," because the amp is that thing on the image there, and I promise that that's not the last pun, so I apologize in advance. So our journey today, what we're going to talk about a little bit is about Lyft's past, the history of our APIs, how we've grown and how we've kind of dealt with those growing pains, and then talk about how our API infrastructure works today. So what we're doing to scale with our growing team and our growing demand, and then a little bit about where we're going. And there are going to be some sort of echoes of previous talks that you've heard today about some of the things that we're working on. So intros and history. So who am I? Greg mentioned my name is Josh Cincinnati. I've been a developer advocate for some time now, but previously I was also involved in business development and product management. So I've had a nice little sampler platter of everything that goes on in a tech company. Lyft, and I'm part of the developer platform team at Lyft. Lyft has a developer platform, in case you didn't know. We have a public API, have had one since 2016. You can do a lot of neat things with that API, but first and foremost is that you can seamlessly integrate ride requests into your applications. And we even have a new API that's in closed beta that allows people to request rides without even having a Lyft account. So I encourage you all to check that out at some point. But more generally, I wanted to talk a bit about why APIs are sort of key to Lyft's strategy in general. In ride sharing, we all sort of live in this world where a driver comes and picks us up, and we hopefully have a 5-star experience. And in Lyft's case, we deeply believe that the drivers are just as important as the passengers. But that said, we know where the future lies, and we know that autonomous is going to be where things go. And in that world, having API access to autonomous vehicles is going to be critical to all kinds of success. So we recognize that, and that's why APIs matter a great deal at Lyft. Beyond that, in the world we live today, our internal APIs are top-tier services that need to work for our applications to function. So they matter a great deal at Lyft. So we could go back a little bit to the days when there wasn't pink everywhere and people still use Sprint. There was an Lyft's API started as one just monolithic service. So it existed in this big service that it was just a tiny piece of. And for small companies with small teams, that's a perfect way to start. It worked great, but we're not small anymore. Since we've unveiled the public API early last year, even just over a year, we've grown 1,000+ employees, and we reached 17 million rides a month by October 2016. The reason I don't have an updated figure is because that's the last public figure I could find, and I don't want to violate my NDA on stage. So to manage that engineering growth, we've been migrating to a microservices-based infrastructure. So before we talk about that, the old way was great in a lot of ways. It offered standardized routing. It was standardized rate limiting. All this stuff was included as part of that monolithic service that we had, and everyone had clear visibility in what changes were being made to this various pieces of the API. So with a small scale and a small team, it's fantastic. But it kind of sucked at scale. If you can imagine this car being the monolithic repo and Homer trying desperately to deprecate it, this is sort of what the experience is like if you haven't done this before. When you're in a state where you have a large number of contributors, you end up in this O(n) squared kind of bizarro Metcalfe's law, where the more people you have, the harder it is to grow with a single service. So there's things like code drift, API conflicts became a hassle, and when we started making endpoints public, all of those issues were magnified. Ditto with merging issues. There'd be stale branches that would require just a hellish kind of Git foo that I've never seen before in order to fix. And then the other problem with having a big service like this is if there's one problem with one separate, unrelated part of the service, the rest of them might cascade and hurt as well. So that's our newest ride type. I encourage you to check it out. It doesn't really fit human beings, but iterate fast. But no, today we now have distributed services, are working toward having distributed services. So if you can imagine each of these circles representing a separate microservice, each one operates independently of the other, but is still interdependent with the other. So the big issue here is how do you achieve consistency across these various APIs, because they're obviously going to be connected to lots of the same services. So this is a little bit of how we do that. We've extracted away those elements, key elements, from those services and turned them into their own microservices. So there is a rate limiting and an auth microservice that those services interact with, and a kind of layer of routing that encompasses them all. And then beyond that, we also have a shared API library for certain key components that need to be shared that all of those microservices interact with as well. And then at the very rim of that border, you'll notice that fun little Envoy logo. Envoy is how we manage to do all the proxying and routing, and it's a service that, that is actually open source by Lyft, so I encourage you all to check that out at some point. I think we just released a new version today too, actually. So let's talk about, like, this graph is pretty, as I do say so myself, but let's talk about what this actually looks like for a request. So a request comes in, maybe someone is interested in requesting a ride for Lyft. It goes to Envoy. Envoy then looks at the route, sees if that IP is maybe, make sure that IP isn't on a blacklist or anything else, and then sends that request to our rate limit service. The rate limit service says, okay, this person coming from this IP, they're not hitting any rate limits. They look okay to go. Go ahead and send that request along. If they didn't, Envoy would simply throw back 429. So then after getting the request back, Envoy takes that request and sends it to our auth service. The authentication service looks at the particular OAuth bearer token that's included with that request and says, okay, is this person allowed to access this particular route? If yes, that's great. Then Envoy actually goes back to the rate limit service, because you need to check after someone is authenticated whether or not they have reached their rate limits. Now, if we were operating with an internal client, it's very unlikely that they'd need to check the rate limits. But for external public API developers, we obviously have rate limits in place, and that we need to be very careful about that for scalability reasons. So after that sort of three-way round trip between auth, rate limit, and Envoy, the request itself gets sent to the rides microservice. And then from there, the rides microservice does its magic. So after going through all those particular microservices, Envoy attaches individual headers that contain relevant information that this microservice might need to deal with. So in this case, you have like client scope, user ID, and so forth. And those permissions are included just as a base 64-bit map as part of the header. Now that microservice could be, right now most of them are in Python, but it could be in Go, it could be in any language, because it's just being kind of handled transparently as a regular HTTP request. So what you'll also notice about this snippet of abstracted code is that we have that nice little Python decorator require permissions that basically leverages this public API library that we run in Lyft or that we have in Lyft, and interprets what those headers have sent to make sure that that service can do the things that it is trying to do. So if someone is trying to post a new ride, embedded in that bitmap with all those permissions is whether that permission is allowed or not. And then on the reverse, sending a formatted response, we have the same sort of mirror image, but with an error response that, again, is handled by our public API library. Cool. Oh, there we go. Oops, sorry. A little late there. So that API library is really critical, in addition to Envoy, for how we can make this work. So that library has a number of those key pieces. It includes documentation, it includes those variety of those decorators, but it's really up to individual teams at Lyft to decide to expose their services, whether publicly or to internal clients. So they can define those things independently of the broader organization, and in fact are encouraged to. And then we also have try to have a strong culture of people contributing back to that public API library. So second Back to the Future reference today. I'm very glad for the first one as well. But we do actually need roadmaps for where we're going. So we are working on building better versioning, as versioning is super critical with APIs. Better error handling, and we want to make it work across a variety of different languages that we use at Lyft. IDL generation, so something that would really help is using some sort of intermediate or a description language to describe how the APIs can and should function to prevent people from making mistakes later on, and to also eventually fill out our open API documentation. And then also eventual support for HTTP2 and push, which will really help, especially as we're interacting with mobile clients. So right now, especially with the open API stuff, we're particularly excited on the developer platform side because it'll really streamline a lot of our documentation and client SDK building, and we're especially hopeful for some README SDK, README Swagger integration with their docs sometime soon. So a few takeaways about going this direction. Generally, it's pretty hard to do this right. When you start off with a small service that works really, really well for a small team, small scale, you're going to encounter growing pains. This is just a well-trod platitude for anyone who's rapidly grown. But you need the right support technology. So that means, in our case, Envoy is an HTTP proxy and also just a shared API library that any microservice can interact with. But culture is just as important as the technology. So service owners that have they really need to actually own APIs as well, and they need to have a strong motivation for exposing those publicly. And beyond that, everyone throws around the premature optimization is the root of all evil, and that's certainly true, but you shouldn't forego that entirely when building your APIs and thinking about what the next step might look like. So always have an optimization path in mind as you go forward on this path. Cool. So thanks very much. As I mentioned, I'm at A City in Ohio. We're at Lyft developers. There are a couple Lyft folks here. Feel free to check out lyft.com/developers. And like everyone else, we are also hiring. So come say hi. Thank you.